Hi, this is Chris, and we are going to check out questions 11 and 12 from section 3 of SAT Practice Test 3. So for question 11, we see this figure, and it says in the figure above, lines KL and M intersect at a point. If x plus y equals u plus w, which of the following must be true? So they give us this equation, but there are also a lot of inherent equalities among these angles, because vertical angles, which basically means angles that are across from each other, are equal. So here, x equals t, or y equals u, z would equal w. So that's a lot of information that we can add to the mix here and see how that helps us. So I don't want to messy up this picture too much, so I'm going to take those out, but let's write down those relationships. So we have, based on the vertical angles that we see above, we have x equals t, y equals u, and z equals w. Okay. So now let's take a look at how that could possibly help us with incorporating that information into the equation they give us. Well, they have x plus y equals u plus w, but we have, and I'll try to color code this a bit, but we have y equals u, which means that these could essentially cancel out. So this gives us another value. This basically tells us x equals w. So we know that x equals t, which equals w, and we already know that z equals w from our vertical angles, so we can say that that's equal to z. So now we know that all four of those are equal to each other. So let's take a look and see how that helps us with our Roman numerals. Before we do any further evaluation, with a Roman numeral question, if you can say a definitive yes or a no to any Roman numeral, you want to see if that helps you eliminate any answer choices. So here, we know that x equals z, because that's part of this four-variable equation here, that they're all equal to each other. So we say yes to Roman numeral 1. We can eliminate c. We know that z equals t. It's also part of this same four-variable equation here. We can say that since they're all equal, z equals t, we say yes to Roman numeral 3. That means we can eliminate answer choice A. So now we just have to figure out whether or not we know for a fact that y is equal to w. And since we have set everything equal based on what we know, we don't have any expression that relates y or u to w. And I'm going to remove those circles just so it's easier to see. But we know the relationship of y and u, but do we have a uw or yw relationship? We don't. We don't see that anywhere, so for this question, it's only going to be Roman numeral 1 and 3. Up next, let's take a look at 12. So question 12 says, in the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to D? And if we look at this, this is a coordinate, and we've gone over this on a previous question, so if you haven't checked that one out, please make sure that you're watching the explanations from test 1 and test 2 as well, because a lot of this is going to be important for us to build recognition through repeated exposure. But any coordinate that you see, coordinates are written x comma y, so if you're ever given a coordinate, you always want to plug in whatever you see in that coordinate space in place of x and y. We're going to plug c in place of x. We're going to plug in d in place of y. Let's see what that looks like after we do that. So then we would have d equals a times c minus 2, and then c plus 4. All right, so that would be what this looks like here if we just plug in these values. We're plugging c in place of x, and we're plugging d in place of y from this coordinate. So now the question asks, the graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to D? So let's think about the vertex. So simple substitution gives us this, but we can see that we still have too many variables here. You have a D, an A, and a C, and our question is just supposed to be in terms of A for our answer, because they want to know what D equals in terms of A. We see that we still have an A in the answer choice, but we shouldn't have a C in there, so we got to find out a clever way to see if we can eliminate that. So let's think about what a vertex is. Well, when you have a parabola is going to have this shape to it. It's like a U shape or a smiley face if you think about it. And so here, x minus 2 is one of your factors. X plus 4 is another factor. If you were to think about what it means for a vertex, let's think about what this tells us. The x minus 2 and the x plus 4. Those factored forms of a parabola are going to give us the x-intercepts, which is basically a way of saying that's where it's going to cross our x-axis. We don't have to know where it falls relative to the origin. We just know that those are going to be points where it crosses the x-axis. So, maybe it's going to be like a positive value here and a negative value here, or, maybe the origin is going to be in a different place. Maybe they're both positive values. But we know that the factored form tells us our x-intercepts. And if we were to set each one of those equal to 0, because that's basically what an x-intercept is, it's where y equals 0. So we would actually have, for your x-intercepts here, and I'm going to color code this part a little bit. So this part of the question, we have x minus 2 equals 0, and we have x plus 4 equals 0. See if we can squeeze that in there on the edge. May or may not fit on, but that would give us x equals 2 and x equals negative 4. These are going to be our x-intercepts. So this would be an x value of 2 and an x value of negative 4 for this particular parabola. Now the vertex will always be directly in the middle of your x-intercepts. So if your parabola crosses the axis at those 2 points, again, we don't have to know the exact positioning on an xy coordinate plane, and we can't know it without knowing the value of A specifically, but we do know the vertex is going to be right in between those values. So here, this is a total of 6 units apart. It would be 3 units away from that vertex. Your vertex will be at negative 1. So here, your x value of your vertex is negative 1. We don't have to know the y value for this, but if we know the x, then we can plug that in, because remember, in this question, x and c are going to be the same thing. So here we have a negative 1 x value for that vertex, which basically means that instead of writing it out like this, I'm going to leave this image here, but I'm going to minimize that and move it over, and we're going to just plug in a negative 1 in place of c, or you can think of it as in place of x. That's going to be our vertex. So when they say vertex, we're really doing d equals a times negative 1 minus 2 and negative 1 plus 4. Simplify that. That's going to be a times, that'll be a negative 3 and a positive 3. Negative 3 times 3 is 9. We get d equals a negative 9a, which matches answer choice A on this question. So there's a lot going on there, and this is a tough question on question 12, but the takeaway concepts that we want to make sure we understand: the factored form tells us our x-intercepts, where we can get those corresponding values, and our vertex, like we see over here with this image, our vertex falls right in between those two x-intercepts, giving us our x value that we can plug in and solve for. Up next, we'll handle the most difficult 3 questions, questions 13, 14, and 15.